In this video, we're going to look at how we can use the unit circle to simplify trig expressions that involve these circular functions. So we already know that the sine and cosine are taken from the x and y coordinates of on the unit circle. So the sine is the value of y, the cosine is the value of x. We looked at and saw that the tangent is the value of y divided by x because we know that tangent is the sine divided by the cosine. And then we can also use the values on the unit circle to evaluate the cosecant, secant, and cotangent. The cosecant is just going to be the reciprocal of the y coordinate for our angle on the unit circle. The secant is going to be the reciprocal of the cosine of the x coordinate. And then the cotangent is going to be x divided by y, the x coordinate divided by the y coordinate. So let's use this fact to help us simplify some trigonometric expressions. So we want to find the exact value of 11 pi over 2 without using a calculator. So when we think about this, we have to ask ourselves, where is 11 pi over 2 on the unit circle? And 11 pi over 2 is actually a little too large. It's larger than 2 pi, so it's not going to be on the unit circle in the sense that we have just looked at. It's past a full rotation. So we have to kind of figure out what angle measure is in the same position as 11 pi over 2 within our first rotation around the unit circle. So the way that we can figure that out is we're going to find an angle that's called a coterminal angle to 11 pi over 2. And all we have to do that is start subtracting full rotations on the unit circle. So we're going to subtract 2 pi from 11 pi over 2. Right? Because if you consider an angle, right, let's say we have an angle here in the unit circle, or just in general in the quadrant, this angle also is the same as this angle, right? Their terminal side is in the same position, but their measure is different. So if I subtract a full rotation, I should be able to get that measure there. So that's the idea behind this problem. So we're going to subtract 2 pi from 11 pi over 2. So 11 pi over 2 minus 2 pi. But in order to do this subtraction, we need a common denominator. So 2 pi is equal to 4 pi over 2. So we're actually just going to subtract 4 pi over 2 from 11 pi over 2. So 4 pi over 2. 11 pi over 2 minus 4 pi over 2, that gives me 7 pi over 2. Is 7 pi over 2 a value within the first rotation on the unit circle? No, this is still bigger than 2 pi, right? It's still bigger than 4 pi over 2. So let's subtract another 2 pi. So 4 pi over 2. So 7 pi over 2 minus 4 pi over 2, that gives us 3 pi over 2. And 3 pi over 2 is in fact a value that we know on the unit circle. So if we consider the unit circle, we know that 3 pi over 2 is on the negative y-axis. It is down here. This is 3 pi over 2. And we're trying to evaluate the sine. Now the sine, so the ordered pair at 3 pi over 2 is 0, negative 1. The sine at 3 pi over 2 is just the y coordinate at 3 pi over 2. So it's going to be negative 1. So the sine of 3 pi over 2, we're saying it should be equal to the sine of 11 pi over 2 because those two angles are coterminal. And we know that that measure is just the y coordinate of the point on our unit circle, which is negative 1. So this whole thing simplifies to be negative 1.